Okay, before starting the exercise, I will make you install some package in Excel. The package is under the menu Data. I have already uploaded it. It is called Data Analysis. Do you have it?
No.
No? No. Those who do not have this package can follow me in installing. So go to the menu File, then go down to Options, then you should choose Add-ins, click, and have a list. You click on the Analysis Tool Pack, and then you go down and click on Go, and then you click on Analysis Tool Pack and click OK. I don't click OK because I have already. Okay, did you succeed?
Yes.
Is there any problem? Okay? No? Okay. Let us read which is the statistical problem. Two operators, number one and number two, perform the calibration of the same pipette. It is the same pipette as in the previous exercises. Data of series 1 is, sorry, this is an error, is the same as a typo. Is the same as in exercise 2, while data in series number 2 are new measurements. I will wait for you if you want. Okay. Just 1 minute, we can wait. Because you should open, sorry. We make break. The question is apply an accuracy test and use 5% as chosen significance. Okay, at first we consider the two data series and we can calculate the confidence interval for each of them. It is not necessary for the test, but it is useful to repeat. Also because when we will calculate f, the parameter f, we should decide which variance is higher. So we need to calculate variance. Okay. So we consider the two confidence intervals. Think that one operator is in one room, the other operator is in another room. Each one is considering only his or her data. Okay. And calculates his or her confidence interval of the mean. Now, I will not retype the functions because I think that you have learned them. They are very simple. Simply have a look. So click on cell B8 and it is calculating the average of the first data series, of the first data. Then you go on cell C8 and it is calculating the standard deviation of the sample for the same data. And then you see that I calculated the variance in cell D8 And I can obtain it in two ways. The first one, the displayed one, is take C8 and elevate it to the power 2. So make the square of C8. But there is also a function called variance. So let us introduce it in a void cell, type equal. Of course, fantasy, the name is var, var dot s, and then open bracket, write the vector with the mouse or typing, and then close the brackets. So variance of the sample of the data contained between A8 and A17. It's the same, of course. Then we have the number of measurements. So in cell E8 we have the function count. In cell F8 we have the formula E8 minus 1. Then in the cell G8 we have the t-student that the first operator uses to calculate the boundaries of his or her own confidence interval. And it takes the value B5 as significance, and F8 as number of degrees of freedom. It is correct. And then the first operator calculates the absolute error of his mean. Oh, sorry, another error. This is 1, of course. And it is obtained multiplying G8, that is T, multiplying C8, that is standard deviation of the first data, divided by square root of E8, the number of measurements of the first operator. Of course, the formulas for the second operator are analogous, but the input is the vector between A20 and A24. Anyway, you can see that the second operator has obtained a bigger value and higher value of standard deviation and consequently of variance. So it seems that the second operator is less precise. But the second operator performed only 5 measurements. So the statistical weight is different, and we should compare them in a correct way by an F-test. And so we will perform the F-test at first. And look, we have to apply this simple formula. I think it is visible in my screen. And we have to compare this F with the subscript A with F tabulated, that is corresponding to our accepted significance, our accepted level of risk. And F tabulated will depend on alpha, the degrees of freedom of the numerator, and the degrees of freedom of the denominator of F. So, first of all, let us calculate Fk. So I click and I write self equal. I will take the variance higher, the second. So click on D20 divided by D8. Of course, the digits are different, but rounding them to 3, they are the same number. This is the result. If I formatted the numbers the same way, they are the same. Okay? Now, we need have F tabulated. All the tabulated functions in Excel correspond to the text I and V. And the first part is the name of the parameter. So we can click type equal, and then F dot. You see, f.inv was the old name of the function that we will use, f.inv.rrt, right tail. Okay? So double click. It is asking which alpha, which significance do you want. The significance is written in cell B5. Then it is asking me to type a semicolon. Then degrees of freedom 1 are relevant to the numerator, so the higher variance, the second series. So the number of degrees of freedom are in F20. Then semicolon, and now the number of degrees of freedom of the lower variance, F8. And close the brackets. And this is the reference. And you see that Fk is lower than F tabulated. This makes us conclude that there is no significant difference between the two precisions. Because the second is a higher number but with lower number of degrees of freedom. They are comparable. We can ask the software to automatically display the result by the logical function. We can try to type directly without using the menu. We can try. So the name is if equal. If open round bracket. Now the software is asking for the logical test, which is the comparison to be done. So the answer will be, the question will be compare Fk with F tabulated and tell me whether the first is lower. So I click on A38, type winner, B38, and then semicolon. Now the software is asking what should I do if the condition is true, and I answer you should type a test, so quotation marks, and the test is no precision is better. Semicolon. What should the software do if the condition is false? It should answer that the first operator is more precise than the second. The first operator is significantly more precise Significantly is always necessary because it accounts for the fact that the decision is subjective because it depends on the significance. So we close the quotation marks, we close the bracket.
So we should write also non precision is significantly better.
Yeah. In this case, the two precisions are comparable. But we want to know, okay, but how much they are similar to each other? Which is the degree of similarity between the two variances, between the two precisions? So we can calculate the p-value for the f-test. And in Excel, the functions calculating p-value are called distrib. So we can type equal the name of the parameter f dot distrib right tail, but the other name is equivalent. It is the old name for the old versions of Excel. So by default, the choice is right tail. Now,
Sorry, Professor. So yesterday we calculated p-value with t dist, giusto?
Yeah.
Right. Okay.
And it was two tail.
And okay. And if we did the same thing, like if we calculated for this problem the p-value with t, will we find the same value or two different values?
No, because the p-value are relevant to two different distributions.
Okay.
Because one is the t distribution, the other is the f distribution. Okay. So we double click on the second. And now answer the question of input. So first, x. X is the value of f identifying the comparison, so it is fk. By analogy, in the t-test, it was pk. Okay. Then, semicolon, the degrees of freedom of the first series, that is the series at the numerator. So it is F20. Then, semicolon, the degrees of freedom of the series corresponding to the lower variance. So it is F8. And I close the bracket and make enter. So the degree of similarity between the two variances is 4.165. Remember that maximum is 0.5, so it is very high with respect to the maximum. Okay? It is 0.16 over 0.5. Okay? It is 32% of the maximum. Do you agree? Okay. Now here I calculate equal what I have obtained divided by the maximum possible value of p-value, 0.5, and multiply 100 to have the percent. It is 33% of the maximum. It is high. Is it clear to you?
Yes.
Okay, do you remember that yesterday I said I told to you an empirical rule for the p-value of t. And I said, if t is at least 0.3, it is enough. But 0.3 is 30% of the maximum, which was 1. Okay? I will try to explain using the whiteboard. Okay, let us compare. I go on with the other PDF so I can update it. Okay, let us compare. P value for t. The range is between 0 and 1. Okay? And we decided that it is sufficient to have p-value at least equal 0.3. Okay? And this is 30% of maximum p-value. Do you agree with this statement?
Yes.
Yes.
So when I obtain at least 30% of the maximum possible value, I am happy. Okay? If we go in turn to p-value of f-test, it goes from 0 to 0.5 because we are considering one-tailed test. So we want the p-value of f at least 30% of maximum. Can you calculate 30% of 0.5?
So, like the important thing is that the p-value is the 30% of whatever is the maximum.
This is the empirical rule.
Okay.
Yes. Okay. So the 30% of maximum is 0.15. It is sufficient for us. This is our empirical rule for analytical chemists. Okay, we agree with this choice. Okay? Now, if we go back to the exercise, we see that our result is higher than 0.15. It is 0.16. So it is sufficient. Okay? Which value should be excellent? Because for t-test it was 0.9. And 90% of the maximum, 0.45. Excellent. Okay? Okay, so our data passed the exam a test said, okay, they are not significantly different. So we can apply the simplified formula for TK. Sorry, this is the Italian subscript, but T observed is as TK. I cannot change the formula, I should retype, but it takes time. Sorry. Okay? Or do you want me to teach you how to input the equations? It is a little boring, but useful. Are you able to introduce an equation? Okay, this is, in this formula, this is TK. Okay? Anyone of you is interested in learning the Microsoft Equation Editor, or do you already know? Okay, I don't. If someone of you wants, I can teach individually how to insert an equation. Okay, this is the formula. This one. Because I have that the two variances are not significantly different, so there is a variance representing the problem. And the variance is this, S squared P calculated from the two variances. Okay? And I inserted this formula in the cell A37. Let us click inside the formula bar to verify that it is taking the correct input. You see, it takes F8 multiplied by C8 squared, so it is μ1 multiplied S1 squared, plus F20 multiplied F20, C20, and this sum is divided by the sum of the two number of degrees of freedom, and all is under square root. So this is the translation of the formula below. This formula corresponds to this formula bar. You are not convinced. Okay? It is a little bit complicated because we have the square root, so many round brackets, but it is this formula. Do you want to type or do we go on? Okay? Yes. Okay, then we calculate the TK by this formula. Okay, in this case we retype. Okay, it is a little bit difficult because there are many brackets, but we will try. Okay, equal. Now we need the absolute difference of the two average values. So A, B, S, open and close the bracket so I cannot forget. Click inside the bracket. Then pick up X average 1. It is in B1 minus X average 2. It is in B20, and this is the numerator, divided by, and we have a product, so we in the denominator, so I open and close the bracket to have the place where I will insert this formula, SP multiplied the square root of the sum of the inverse of the number of measurements. So now I have to put here SP, it is in A37.
Yes.
Multiply, now I have a square root, so QRT, open and close the bracket, otherwise I will forget. And inside the bracket of square root, I should type 1 over N1. So 1 divided by N1 plus 1 divided by N2, that is E20. I hope I didn't make errors. Type enter, and this is the result. TK is 033 around. Okay? Now we know that if we work with significance 5%, means that the order of magnitude of t tab is 2 or higher. Because when we move 2 sigma from the maximum of the Gaussian curve, 2 sigma corresponds to 5% in the tails. So our t tab will be 2 if we make infinite measurements, or higher than 2 if we make a finite number of measurements. In fact, you see the t tab for the test is calculated here, 2.16. Let us calculate the t tabulated for the test. And remember that the test contains all the degrees of freedom that we have considered. So let us calculate t tab equals t dot INV dot 2t open bracket. Okay, the significance is still in B5. Then we need to type semicolon. And then the degrees of freedom for this accuracy test is the sum of the 2 degrees of freedom. We are comparing the 2 average values, and each of them brings a certain number of degrees of freedom. Me1 associated with the first average, Me2 with the second. So here we should type the sum of the 2 degrees of freedom. So click on F8 plus F20. And then close the bracket. And this is the tabulated T, corresponding to a risk of 5%. We can see that the TK is lower, but we make the if function decide. And this is written in the cell E37, click on E37, click inside the formula bar and read what I have typed. If B37, that is decay, is lower than D37, that is T tabulated for the test, then type the means are not significantly different. Otherwise, you type the means are significantly different. Okay? And the decision is they are not significantly different. But I wanted to calculate the degree of similarity between these two average values. So I calculate a p-value of t-test. Let us calculate together. Equal. The parameter considered is t dot. I am asking for a p-value, so the function is called this. So dist, 2 tails, because this is a t-test. It is possible that x average 1 is higher than average 2 or vice versa. So I click dot to t, open the bracket. Now the input is tk. And the degrees of freedom they are calculated in the cell C37. You see, they are 13, 9 plus 4. So click on C37, close the bracket, and the result is 75%, very, very high. This is very good result. They are very, very similar, because the maximum possible value is 1. Okay? Is this clear for you? Okay, now student can ask me, but should I make all this effort every time I want to perform t-test, f-test? No, of course you have the ready functions in the package that we have just uploaded. So click on the menu data, go to the tool data analysis, and look for this function, f-test 2 samples for variances. Did you find it? F-test 2 samples for variances. Okay? This dialog box is not intelligent, but we know that the first series should be the one with the higher variance. Okay? So here we have to insert the second series from A20 to A24. Variable to range is the one with the variance lower. So here I insert the vector B8, B17. A8, A17. Then alpha is proposed to be 5%, it is okay for me. Then I can choose to output the results in another sheet or inside this sheet. I usually choose the first option. So I click here on output range. Then click inside the box and type the name of a void cell where the output will be written. For instance, I click on Q25. Pay attention because it overwrites. So if you have other results, it will overwrite. Okay? And this is the result, identical to the one that I had already obtained. And I have highlighted with colors the parameters that we have calculated together. You see in brown, it is Fk. Okay? In green, it is the p-value for f-test. in pink, it is the F tabulated. In my research work, when I perform an F test, my eye look only one result, the green one. Because it is this p-value telling to me if the test was passed or not, was okay or not. And I see a big p-value, more than 30% of the maximum, so it is okay. Now we can obtain the other result for the t-test. So click on data analysis. Look for the function named t-test to sample assuming equal variances. That is our case. If we had obtained that the two variances were different, there is a function. So look for the t. The function in our case is this, t-test to sample assuming equal variances. But if it were not, the right function is the other below, two samples assuming different variances. So I selected first, okay. Again, I input first the series with the higher variance, then the other one, then I click on output range, click in the box.
What happens if here I put before the lower variance? Because essentially
it happens that the t calculated could be negative, and this means that the mean value that you are considering, the first that you have considered is lower than the other, but the absolute value will be the same. So I click on output range and I choose Q37 or 38, and this is the result, and I colored in gray the number of degrees of freedom of the test, which are 13. In blue I type the TK, and in orange the p-value, and in yellow the t-tab. And I deleted the one-tail answers because I don't want a one-tail test. I want a two-tail test. And when I perform this test, I look directly to the orange result, p-value. Because this is what informs me about the success or not of the test. So I have found that for the two series, I have trueness, I have precision. So the result of the second operator with respect to the first is accurate. Okay, but it might happen that the two mean values are close, but precision are different. It may happen that the two mean values are distant, but precision are similar. Okay, all the possibilities are, and also different average values and different precisions. In this case, if the first operator was the reference for the second is accurate. Now you can try to make exercises by yourself with the two series of measurements of volume or two series of measurements of density. Okay? Here the question is, please perform t-test and f-test. You don't need to calculate the confidence intervals. But you need to calculate for each series at least the mean value and the variance. And then you can perform the test manually. Otherwise, if you are bored with the statistic, you use directly the ready functions in the analysis, in the data analysis box. Okay, this is your task. And we have 1 hour for making the exercises. Remember that you have always the possibility to duplicate my sheet and insert the new data. I advise you to try by yourself and then verify by duplicating the sheet and inserting the new data. Look that there is a case in which the number of measurements are higher or lower. For instance, in this case, for the exercise that we have done together, we have 10 measurements in the first operator and 5 measurements in the second. But if we go to the case of this, we have only 6 measurements for the first operator and 4 for the second. In this case, in order to make the formulas update, you should do like that. If you want, you can follow me. So duplicate this. Go with the mouse on the name of the sheet, click right, move or copy, create a copy, move to the end, for instance. Okay, this is the copy. I want only 6 values in the first series. Then, sorry, I do like that. I delete 4 lines. I select 4 lines, full lines. Okay, so I click on the name of 1 line and go down 4 lines and then click by the right, delete, and you see that the function has been updated. If you want to add some result, you should do like that. For instance, here we have 15 measurements for density. Here in the copy we have only 10. So I select 5 lines and I make insert. And then I insert here the new values. And the function has been updated. Okay, these are tools to quickly obtain the result, if you want. Okay, that's all. If you want, of course, you can take a break.